Good afternoon, everyone. Today I am taking a class on FDU. FDU is Fire Detection Unit and it's interfacing with VCU. It is located inside SB2 panel of the three-phase locomotive. It senses any fire detection in the machine room and gives information to the locopilot in the car. And there is and it also indicates if there is a failure in the suction system. And MCB 127.91 can be used to turn on and turn off the FDU. It is the MCB for 24 volt DC-DC converter. Inside the machine room, there are pipes located throughout the machine room, and from there it will suck the air and it will give to FDU. Inside what is inside the FDU? FDU has two sensors inside it, and it will detect the smoke, and there is a suction unit. It will collect the air from different parts of the machine room. And for electrical connection, we are using a 25 pin sub D, and there are visual indicators for a fault and malfunction. This one for glows with FDUs in operation, and it is for fault malfunction indication. And there are two alarm 1 and 2. And the whole thing is housed in a metal case. This is the voltage description. 24 volt DC is used, and the current consumption during a normal operation is around 200 to 250 milliampere. This is the physical description. The dimension is 144 into 252 into 350 mm approximately, and the weight is 7.1 kg. And protection class is 1 IP 40 for the unit and IP 43 for the detector. And the operation temperature is around minus 25 to 70 degrees. As I said earlier, inside an FDU there are two sensors. We are using an optoelectronic sensor that it should be it should sense the smoke from all types of smokes. It should be able to detect, and the sensor should be according to global standard EN 5T4 7/9. The standard is that it should be able to detect smoke like a wooden smoke caused by wooden fire and up to open liquid fire. And it should able to detect smoke from all the 360 angle, and also should be resistant to corrosion, heat, cold, and humidity. And it should be also have the resistant to shock and vibration also, and must also resist electromagnetic interference. This is the inside of an FDU. These are the two sensors. This is the LED indicator card, and this is the power control unit. The principle of operation of a detector is that light, when it travels through a smoke, it gets scattered. Usually, light from the source is sent to the receiver. If there is a smoke inside, the receiver will get the light. If there is no smoke, it won't get any signal from the receiver. And after only 3 pulses only, the control unit will get the signal. This is the diagram. That is, this is the light source and this is the receiving end. Usually, when the detector is clean, the light travels and it will be placed so that no reflected light or no direct light is entered in the sensor. If there is smoke, it will get scattered and the receiver will get the light. As I said, the smoke is collected from all the parts of the locomotive and is sent to the FDU. And there is an airflow monitoring that if the pipeline is broken or it is blocked, the light flow will be monitored and the fault generator is transferred to the VCU. As I said, there is a suction system that it will collect air from all parts of the locomotive, and the pipeline is um, around all the four sides of the locomotive, and it's approximately 30 meter in length, and it will have small openings, and the size of the opening is the function of its distance from the FDU. In case of a pipe fracture, uh, there will be a airflow sensor test socket across less than will be greater than 1 volt if it is a fracture, and the voltage will be less than 1 volt if it's a blockage. And when a fault is detected after a time delay of 2 seconds, using a time delay settings, we are transferring the fault to the VCU. This is the back side of an FDU. This is the earthing point. This is the 25 pin sub D, and this is the PG29 coupler. This coupler is used to connect the FDU pipe to the VCU, through which the air gets inside. For calibration, in case of an ARC FDU, the calibration we don't need any multimeter. Just there is a button like this inside the ARC. Just press this button, it will calibrate automatically. And for a Trolex and a higher FDU, we connect a multimeter across this, and if the voltage across it should be plus or minus 50 for higher and for Trolex it is plus or minus 10 millivolt. These are the calibration limits for other FDUs. Here we are using only Trolex, Hyrex and AR. This is the circuit diagram for VCU. This is the fire detection equipment, and this is the sub D pin. As I said, 25 sub D pins are there, and across 1, 4, positive 24 volt is coming from the DC-DC converter, and this is the earth 2 and 15. And for 8 and 7 across, it is alarm 2, and 5 and 4 pin, it is alarm 1, and 23 and 10, it is failure. And accordingly, this message will be given to VCU. And it will be coming from the control electronics. And here, this is alarm 1 and alarm 2 interlock. When these two interlocks get closed, the supply to the buzzer located in the cab will be on through this diode. As I said, this is the 25 pin. This is the one for 250. This is for positive 1 and 14. Sorry, 1 and 2, 14 and 15 for the negative. And this is the same thing. And there are 3 messages for FDU: 1501P1 for fire detection, and for that LSFI start blinking, BPFA glows, and the buzzer will act. And 1501P2, it is a fault detection, fault in the FDU. And 1502P2, it is the warning message. Only BPFA glows, no buzzer will act. This is the testing of FDU. In the For this, FDU is connected to a 300 mm pipeline, and there are three openings, N1, N2 and N3. For a normal condition, this N1 is in closed condition, N2 and N3 are open. Then the voltage is measured. It should be plus or minus 50 or plus or minus 100. And for a blockage test, we will close the N1 and N1 and N2 is closed, N3 will be in open condition. Then we measure the voltage. The voltage should be less than minus 1 volt. And for rupture, all the three holes will be opened. The voltage should be greater than 1 volt. In these conditions, it would show the malfunction of FDU. These two conditions. This is the FDU test bed. FDU, this is the 24 volt power supply. This is the pipe we connect, and this is our FDU. And maintenance, during every first commissioning, it is calibrated, and during every schedule, we have some checkpoints. That is, the pipeline should be, holes should be clean, and all the pipeline should be intact. There should be no breakage, and it is we should the mounting should be correctly, and the PG union should be tightened. Most of the cases, there won't be, the PG union will get slack somehow. And the sub D should be inserted correctly. And in every major schedule, the air filter inside the air FDU is getting changed. It is a must change item. Thank you.